now we're going to move away from memory and that portion of cognition and go a little bit deeper into the whole process of thinking, looking at how it is that we solve problems, how we take in the world around us and perceive certain aspects of it. So that's what this set of video notes will be about. When we talk about thinking, or in a more formal term, cognition, it's referring to how we carry out a process that involves our knowledge, our level of understanding, our ability to communicate, and our ability to remember. So cognition is, even though we kind of pare it down to simply just thinking, it involves far more than what we would perceive that to be. There's lots that kind of falls within that understanding, so it's important that we take a look at that. So one of the things we've got to take a look at when we're looking into the more in-depth understanding of thought and cognition is concepts. Concepts are how we mentally group similar things, whether those things be objects or events or people or ideas. Okay, so when we're looking at this image here, we can see that these are all chairs. They're all slightly different in terms of how they're presented to us, or what they look like aesthetically, but they all have common features that define them as the concept of a chair. They all have, for example, a seat. Okay, you can see that they all have a back that goes along with that seat, and they all have legs or a base. Okay, so this would be something that would help us to see that a chair and our concept of it is kind of revolving around common features that make those similar. Now, the way that we got to look at how we develop a concept, how our cognitive processes further that, we can form some understandings that we have of concepts by definitions. So if you were to look at a triangle right here, for example, its definition is an object that has three sides. Most of the time, though, what we end up doing is we form mental concepts that we have through more mental construction and mental imagery by looking at a best example of a concept. So we call that then a prototype. So an example of this concept would be looking at, say, a bird. Okay, our concept of a bird would be to think of things like they all have beaks, they have wings, they can fly, okay, they have these funny little looking feet. But if we were to look at it that way, then if you were to pick out the best prototype from these three options, you would go for the robin right here, because the robin fits into that prototype. It has a beak, it has wings, it can fly. But on the other hand, penguins and ostriches don't. They can't fly. They have everything else except that. So they wouldn't necessarily fit into that best example of a concept. So that is prototype. Now, another thing to keep in mind when it comes to how it is we developed our concepts of things, we represent typically within our mind our concepts as schemas. A schema is just a generalization that we develop about things or events or people or objects or certain categories, okay? So schemas help us understand what a concept is, and what enables us to kind of generate expectations about what a concept does. So if you look back at that concept of a bird, okay, and we established our prototype, we made generalizations about what all birds have in terms of similarities: a beak, wings, they can fly. So our schema is what helped us to enable us to understand that concept of what a bird is. Another example would be to think about a police officer. Your prototype or mental image of an officer will probably have certain generalizations that go along with it. Typically, we would perceive them to be, fairly young, perhaps, in decent shape. We would think that they wear a uniform, they carry a gun, okay? And so we would have that general understanding, a prototype, that specific kind of best example of a police officer. And then we would look at some of the common features that all have. And so many of those common features would end up helping you to develop that prototype as well. So you'll see the same thing. They wear a badge, they're younger, for the most part, relatively fit. They wear uniforms. And then as we develop the schema that we have towards police officers, when we are presented with one, we would expect them to wear uniforms and to help people. So, when we are presented with an individual who is not necessarily in a uniform, for example, and they flash a badge and they say that they are they're not on duty at that present moment, that wouldn't necessarily fall within our schema or our concept or our prototype of a police officer, because it's not presenting us with the generalization or the mental image of the best example that we typically have of that person. So hopefully this wasn't terribly confusing for you, but obviously we'll spend some time in class working through giving some more clarification to these later. Now, there are 3 ways to go about problem solving, and these can get a little bit confusing as well. The first way to go about doing it is something called an algorithm. Okay, so this is a very step by step methodical logical procedure. Okay, it guarantees solving a particular problem. Okay, so it exhausts all level of possibilities before arriving at the solution that is necessary. So it is much more accurate. Problem is they take a very, very, very long time. Computers use algorithms, okay? But there's a way that we can go about at least looking at this concept in a way that can be easier for us to understand how we could operate on it. Let's say, for example, that you want to go to the grocery store and you want to find oatmeal, okay? It's kind of random, but we'll go with it. Using an algorithmic process to problem solving, you would literally go up and down every single aisle until you found the oatmeal. Okay, so you exhausted all possibilities of where it could be in the grocery store. And then once you did all that, you were able to kind of logically and methodically rule out where it was until you found it in its proper spot. So that's algorithms. Now, the flip side to that is a heuristic. A heuristic is when we have a much more simple thinking strategy that enables us to kind of get around the long process of time for an algorithm. Heuristics make it easier for us to kind of sift through a lot of that step-by-step process of an algorithm, and to solve things and make judgments a little bit more efficiently, okay, so to do it much more quickly. They enhance the likelihood of success, but they can't assure it the way that algorithms can, okay? We know that for the most part we can more than likely be accurate in using our heuristics, but we're not always going to be 100% positive that they're accurate enough. It is much more speedy, okay, obviously, it's a lot quicker, and you can see down here in the example, same thing, we're going to use oatmeal again at the grocery store. Instead of, running up and down every single aisle to make sure that you can find the item that you want, instead what you do is you read the signs at the end of the aisle and you look for, cereal, and you know that that is basically going to be right around in that area, and so then you look to that aisle first rather than looking through every single one of them, okay? So it is much quicker, okay? But at the same time, it is much more error prone than algorithms, and we'll get into that in a bit. Another way to attempt to solve problems is through insight. We learned about this when we covered learning in Unit 6, and we talked about Kohler's studies with chimps. Remember Sultan and his ability to use kind of the items that are available to him to be able to solve the problem of getting to his banana. Insight involves a sudden realization that we have, kind of that aha moment, if you will, that enables us to figure out the solution to an issue. Oftentimes what insight does is it will use some prior learning and experience and some level of initial trial and error to figure things out and to gain a level of insight. But this is definitely something that is used by both humans and animals alike. And we've done a lot of scanning of brain imaging to see if it's possible for us to basically know when a level of insight or that aha moment kind of happens for us. And interestingly, we do have that ability. Brain imaging and EEG studies show that when insight, kind of hits for us and there's that aha moment, oh, I know what the answer is, it activates the right temporal cortex, okay? So it activates our temporal lobes, specifically on the right side of our brains. And the time between not knowing the solution to knowing it, when we see these brain scans is only 0.3 of a second. It's very, very quick. Okay, so it is an interesting kind of piece to our ability to understand how we problem solve by having those imaging techniques that enable us to see what physiologically happens to our brain as we're going through it. Now, there are several obstacles to problem solving that we do need to take a bit of time to discuss. The first is going to be an issue with something called fixation. This is our inability to kind of see a problem from a different kind of angle. Okay, this is an impediment to problem solving because we just keep finding ourselves going back to that exact same manner in which we want to solve the problem, and we're not taking a look at other options for us. So there are two types or examples of fixation. The first is mental set. This is when we kind of fall back into old patterns of problem solving and they continue to stick with us, and so we just really struggle to be able to answer or solve a problem because we can't get ourselves out of that old pattern of things. Functional fixedness is another one, and this is a really interesting kind of example because it gets to a couple of scenarios that I've got some examples for you that will be, I think, pretty helpful. Functional fixedness is when we have a scenario of fixation, but it's when we think of only one familiar function for the object that we are, attempting to look at, or, a problem that we're looking into. So, for example, name the different ways that you could use a fork. For most of us, the first way that we would take a look at it would be, we use it to eat. And, that's pretty much about it. Well, if you look at movies like The Little Mermaid, where Scuttle, the bird in that movie, ends up showing to Ariel a fork, and he calls it a dingle hopper, and he tells her that it is how she could, it's something she could use to comb her hair. That is very much a scenario of getting outside of the box in terms of problem solving, because none of us would really sit there and think to ourselves, okay, let's use a fork and let's use it to comb our hair. But it has a function with regard to that it could be used that way if we chose to. Another scenario would be taking a look at if you need to screw something into a piece of wood and you don't have a flathead screwdriver. What you could use instead would be a coin. You could use something like a dime that is very thin and would be able to sit in there and kind of use it to twist as if it were a screwdriver. So in this scenario then, functional fixedness would be our inability to kind of look outside the box and to use those objects in multiple different ways outside of their familiar functions. Another issue to problem solving is confirmation bias. This is when we have a tendency to kind of look for information that confirms what we believe, okay? So the basic just behind this is when we think we're right, we're going to look for evidence that proves we're right. We're not going to sit there and say, oh, you don't think I'm right? Okay, well, let me look to prove you right. We do it the complete opposite. We look at it and we say, no, I definitely think I'm right, and here's what it is, and I'm going to prove it to you. So we look for evidence that's going to go about supporting our ideas, and we'll tend to dismiss anything that seems to be contrary to our way of thinking. So let's say, for example, in this little scenario down here, you believe your boyfriend is faithful. And so instead of noticing that he's getting text messages from other girls and suddenly isn't available to go out with you the way that he once had been, so you pay attention to the fact that he calls you once a day, even if it is for a few seconds, and so it still means he's faithful and he is committed to your relationship, and because he also brings you flowers when he's able to take you out on a date, you pay attention to those things. So you kind of put blinders up in certain scenarios. If you're sitting there, gentlemen, and you guys are having conversations with somebody about how you think Peyton Manning is the greatest quarterback of all time, especially since he came back from that pretty serious neck surgery that he had to have just a few years ago. And somebody says to you, no, that's completely not true. I don't think that's it at all. And they have someone else that they perceive to be a much better. So you're not going to go onto your phone and pull it up and go to Google and look up someone else's stats to prove you wrong. You're going to go and you're going to look at Peyton Manning's scores and his QB rating and all of the different touchdown passes that he's made, because you want to prove you're right.